Okay, in this section for rational functions, what we're going to do is we're going to talk about discontinuities. So if we're looking at this particular function, I see that it's a rational function, and I know that because I have the little fraction, I'm going to have some discontinuities that are going to be apparent to me if I factor. So my first step is always going to be to factor where you can. So here is my function in factored form. X minus 4. Okay, so that's going to be x minus 2 and x plus 1. So I see that I have a vertical asymptote looking at the denominator. I have two of them. One is going to be at x equals 2, and one is going to be at x equals negative 1. So when I try to sketch this, I have to pick up my pencil at those points. Therefore, it is discontinuous at those points. So let's just look at what that function would look like. And you should graph these things as you're working through the midterm review packet. So very quickly, my graph looks something like this. Where I have the 2 is right here. Where I have the negative 1 is, say, right here. So let me just do that a little bit better so that it's in proportion. So that'll be a 1. So my 2 will actually be here. So I'm going to change colors, and I'm going to give you a little bit of an asymptote right here and right here. So when I look at my function, I see a couple of things. First off, I know, because of what the function is, that it's going to cross my x-axis at 4, and that's because of this. So what's happening is, well, let me take that back. It's going to cross at 4 over 2, so it's going to cross at 2. So this is going to come down. Let me change color again. This is going to come down about here, go a little bit lower, and then come up. Okay, so that's part of my function. Then I come to the asymptote and I don't cross it. And over here, I come up and I respect the asymptote. So where my function is discontinuous, if I was going to draw it, so watch as I go over this. If I draw it, this is what's happening. I start to draw, have to stop. I jump, and I start drawing again here. Have to stop. I jump, and I have to draw elsewhere. So where is it discontinuous? At negative 1 and at 2. So those will be my answers. 2 and negative 1 mark where my function is discontinuous and is related to the vertical asymptote. Problem 11 says find the values of x for which this function is discontinuous, and label these discontinuities as removable or non-removable. So I tell you here that asymptotes are non-removable. That means you can't cancel them. Wholes are removable. So our first thing we're going to do is we're going to factor. Here we're factoring, and then factor the denominator. So you can see that factoring is going to be very important. So if you're weak at that, you want to practice your factoring. Here's my factored form. What I'm noticing is that I can cancel this x minus 2 with this x minus 2. That tells me that I have a removable discontinuity at positive 2. So here is going to be my answer. I have two discontinuities. One is at x equals 2, and one is at x equals negative 2. Okay, where x equals 2, that is removable. So you would indicate removable. Where x equals negative 2, that is not removable. Okay, let's look at this graph. If I were to graph it, and again, it's a great idea to graph these things. You own a graphing calculator. Use it. here's my graph. I see that at -2, what is happening is I have an asymptote, and my function is not crossing that vertical asymptote. All right, at +2, I have a hole, but that's considered a removable discontinuity. How can you remove it? You can factor and cancel. In problem number 13, they ask us to find both the vertical and the horizontal asymptotes. So, quick lesson, vertical refers to the denominator. So our first thing we're going to do is factor where possible. Looking at the top, nothing multiplies to 14 and adds to a -1, and subtracts to +1. Therefore, the top is not factorable, so I'm not going to worry about factoring. That tells me that I do not have any removable discontinuities because I can't remove them by factoring and canceling. Here is a perfect square on the bottom, so when you break it up, it looks like that. So the bottom is going to give me my vertical asymptotes. So the vertical asymptotes will be the lines, and you have to write them as lines. X equals -1 from this one, and x equals +1 from the second factor. So your factors equal to 0 and solve. Okay, to get your horizontal asymptotes, you have 3 options. All right, if it is top-heavy, so if it's top-heavy, meaning that the power on top is greater, there are none. If it's bottom-heavy, meaning that the power in the bottom is greater, then your horizontal asymptote will always be y equals 0. Okay, we have the balanced case. When it's balanced, and here I have a power squared on the top is my highest, and squared on the bottom is my highest, that's balanced. Then you take the coefficient of, we'll say the HP, the highest power. So in this case, my horizontal asymptote, which I have to report as a line, is going to be y equals, take off the coefficient, 2 over 1, so we can just say y equals 2. So you need to memorize how to get vertical and horizontal asymptotes. Just another point, when we do horizontal asymptotes, you can get an indication of the value by thinking about what would be the limit as x goes to 0. That limit would be 2 in this situation, and therefore your horizontal asymptote is the line y equals 2.